Alright guys, we are working on 7.6 properties of logarithms. This is the homework tutorial, and I have Madison Ray helping me right now, so we're fixing to do problem number 1. Alright, we're going to be writing each expression as a single logarithm. Madison, what's our first problem here?
Just read it.
Yeah, just read it. Just talk out.
Log, what is that?
Base 3
Base 3
of 9.
of 9 plus log base 3 of 24.
Okay, talk up a little bit because it's
Oh, okay.
that or get closer to the deal. So.
Log base 3 of 9 plus log base 3 of 24.
Okay, when we are adding logarithms with common bases, what do we do with our x's?
Find the common factor.
What do we do? How do we do that? When we find common factors, what do we do? We're not finding common bases. What are we doing with our x's? When I add, I do what?
I hate this.
No. Okay, when we are working with adding two equations together, we're multiplying the x's. Okay?
Okay.
Okay, so we're going to write log base 3. And then in parentheses, I want you to put 9 times 24. Okay? So now, what's 9 times 24?
216.
Okay, so write log base 3 of 216. And there's your answer.
Oh, okay.
Okay?
Makes a lot more sense.
Okay, let's do problem number 3. So log base 2 of 7 minus log base 2 of 9. Okay, now when I'm subtracting, what do I do with my x's?
Divide them.
I divide them. Good. So log base 2
And then it's 7
is
over 9.
7 over 9. The first divided by the second. And there's our equation.
Oh, okay, well that one's even easier.
That was even easier. Okay, let's do number 4. You want to do another different color?
Oh yeah, true.
There we go. Okay. So number 4 is log 3 of 8 to the 5th power. Okay, now that 5th power, it moves, it changes. What does it do? Where's that supposed to go?
In front of the log, right?
It goes in front of the log, yeah. So 5 log 3 of base 8. Knows it?
Oh, okay, that makes sense.
Makes sense? Change colors and let's do number 6. Okay? I'm going to let you do this one by yourself and explain it out.
Alright. Log, and it's like of 5, right?
Log 5. What's
Log 5.
what's my base there?
10.
10. That's our common base.
Plus log base 10 of 7.
Okay.
Then you just multiply 5.
Multiply what?
5 and 7. So, and then it comes out to log of 35.
There we go. Good deal. All right, now we are expanding logarithms and we're simplifying. This is number 7. We have log base 3 of 27x. And I've got Bailey here with us too now. So Madison Ray's still here, but Bailey's here too because he needs to understand what it is we're doing.
Yeah, Bailey. Yeah.
Gentlemen. Yeah, Dakota's standing right here too. Okay. So.
And Kevin. And Ron.
So I'm guessing that y'all all don't understand. Then get over here. Okay, log base 3 of 27x. In the last, in the last section, we went from expanded form to single expression. Now we're going from single expression to expanded form. Okay, Bailey has a question. Bailey, what's your question?
Why would we want to take something simple and make it harder?
Okay, we're not making it harder. We're expanding it out because from simple form we expanded out to the full form of the parent function, which has the a, the b, the h, and the k. Because our exponent of x goes in and becomes our a, and if we can simplify an equation down to just a number, that becomes our h or our k. Okay, so and our base is already our b.
I guess knowledge is power.
There you go. Okay, all right. So let's expand this out. We have log base 3 of 27x. When I added two equations, I ended up multiplying, right? So if I've got two things that are multiplied together, when I split it out, what am I doing?
You're adding.
I'm going to add it.
So
I end up with log base 3 of 27
plus log base 3 of x.
Correct.
Hey.
Bailey didn't bring a pencil. Watch out.
Here's a pen, Bailey.
Ah, thank you, Dakota.
That's my pen.
Here's even better. Here's a pencil.
Here, thank you. Hey.
All right.
Thank you, sir.
Let's do number, what is that number?
12.
So that was
Number
the
9.
answer.
That
Okay.
was the answer.
Gee whiz.
Number
that
9.
easy.
What's the answer for number 9?
We're fixing to do number 9.
Oh, okay.
Log
So log base 4 of y squared times z to the 3rd power. Okay, what's my first step? Bailey, what's my first step?
Expand.
How am I going to expand that? I'm going from,
Adding.
I'm going to add. So I'm going to split out the y squared and the z to the 3.
log base 4 y squared plus log base 4 z cubed.
All right, now I've got log base 4 of y squared and log base 4 of z cubed. What do I notice about my x's?
There is no x.
They've got an exponent.
They both have exponents. So I'm going to take my exponents and move them where?
To the front of the log.
To the front of the log into the a position.
So 2 log base 4 of y plus 3 log base 4 of z.
Correct. 2 log base 4 of y plus 3 log base 4 of z. Questions? No questions? Okay, do number 10.
Okay.
Ah, yes.
Log base 5 3 squared over x.
Okay,
Oh, that looks
log
wrong.
base 5 of 3 squared over x.
You couldn't tell that was squared.
Okay.
32.
So, I have 3 squared over x. What's my first step, Kevin?
Subtract.
Okay. Why am I subtracting? What's telling me to subtract?
Because those are dividing.
Because I've divided by x, so I'm going to split those out by making a subtraction.
Good job, Kevin.
Good job, Kevin.
So log base 5 of 3 squared minus log base 5 of x.
Correct. All right. Now I have log base 5 of 3 squared Ty, tell me what's going on with that one.
On which one? Number 10?
On number 10. We've already split out the x and gotten it to log base 5 of 3 squared minus log base 5 of x. What happens with that 3 squared? What am I doing?
It becomes, I don't know.
What does that 3 have? It has a what? It has an exponent. Thank you,
So
Wes.
it goes over to the,
So where am I
it goes over
moving?
to the left. Like
It goes over to the left in front of everything, right?
So
Okay.
2 log base 5 of 3 minus log base 5 of x.
There you go.
That's it?
And that's it on number 10.
Wow.
Okay, number 12.
Skipping over 11.
We're not doing the middle column, remember?
Maybe, yeah.
Or, oh yeah, that's right, 7, 8, and 9. You did the middle column for the
Yeah.
other way.
So-
Yeah.
Log base 10 of 8xc to the 4th power.
Okay, log of 8 times x times z to the 4th. So, what's my first step? What do you think? Who thinks?
Separating.
I can't think.
Separate it out to addition.
Yeah, so, thank you,
So-
Brian. You told me first, so I heard that. What's your
Log
next?
of 8 plus log of x plus log of z to the 4th power.
Okay, so log of 8 plus log of x plus log of z to the 4th. Ryan, what's my next step? Talk up loud.
The exponent?
The exponent on z. Yeah, what am I going to do with that exponent?
You're going to divide?
No. Good try.
Move it to the front.
We're going to move it to the front into the A position.
Yeah.
So, not into the very front, but just on the front of the log that it's with.
So log. Oh, why do I keep writing a g there? Okay, log of 8 plus log of x plus 4 log of z.
It's okay, Madison. I always put HG with the O's.
All right.
Too.
Good work. All right, we're gonna look at a couple of formulas here. We're gonna do the change of base. Madison and all the guys from second period have left because second period was over with a little while ago. In fact, third period is over and now it's fourth period. We're going to do the change of base for number 14 and number 16. Number 14, we have log base 32 of 4, and we can see that we have a base of 2 for each one. So 32 is equal to 2 to the 5th power, and 4 is equal to 2 to the 4th power. I mean, to the 2nd power, excuse me. Okay, so we're going to take log base 2, because we're using our common base, of m, so that's the 4, divided by log base 2 of 32. Okay, so log base 2 of 4 is 2, log base 2 of 32 is 5. So the answer is x equals 2/5. Okay, all right. Okay, last problem. Log 4 of 12. Now, log 4 and log 12 do not have common bases, so we're going to use the base 10 method. So we're going to do log 12 divided by log 4. And log 12 divided by log 4, when we put it into the calculator and go to 3 decimal places, is 1.792.
Period 7.
And that is it for our video for today. Have a good afternoon. I'm fixing to post this, and it is here at lunchtime. Thanks, and have a great day. Bye.